All right, sample problem 5.2 deals with the volume-pressure relationship, which is essentially Boyle's law. It says Boyle's apprentice finds that the air trapped in a J tube occupies 24.8 cubic centimeters at 1.12 atmospheres. By adding mercury to the tube, he increases the pressure of the trapped air to 2.64 atmospheres. Assuming constant temperature, what is the new volume of air in liters? So what I'm going to do right now is I'm going to write down the relationship between pressures and volumes that we get from Boyle's law. So essentially, if you're reading the text about Boyle's law, the main gist you need to get is that P1 V1 is equal to P2 V2. Okay? So what this means is that the first pressure times the volume is equal to the second pressure times the new volume. So if I'm changing the volume, right, then the pressure is going to change. Essentially, that's one of the other main things we get from Boyle's law. Not only just this equation, but the realization that if I change the pressure of a gas, the volume changes. All right, so let's see here. I'm looking for the new volume. So I'm going to call that new volume V2. I'm going to let it be V2. So I'm going to solve this equation here for V2. So I've got V2 is then going to equal P1 V1, and what I have to do is just divide both sides by P2, right? I've just done a little bit of algebra there. So that's going to equal, okay, so let's see. The first pressure they gave me was 1.12 atmospheres. The first volume, so V1, is going to be 24.8 cubic centimeters. Divided by, they're changing the pressure to 2.64 atmospheres, so that's P2, and we want to know what the new volume is going to be there. So let's see, V2 is going to equal. Now let me check my units here. I've got atmospheres in the top divided by atmospheres in the bottom. They're going to cancel out, and I'm going to be left in the volume of the units cubic centimeters. So let's see what I get here. I've got 1.12 times 24.8 divided by 2.64 equals. All right, so I got 10.5 cubic centimeters, but that's not the units they're wanting, right? They're wanting this answer in liters. So I've got to use some conversion factors here. And you'll remember when we talked about volume, in 1 cubic centimeter, there's 1 milliliter. And there are 1,000 milliliters in 1 liter. So let's see, I've got cubic centimeters divided by cubic centimeters, milliliters divided by milliliters. That's going to be equal to 0.0105 liters. Let me squeeze that unit in there. All right.